So here we're going to look at some more relationships between the angles and our triangles. So let's have a look at this first diagram here. And what you can see is that our triangle, our original triangle with an angle of theta, has been moved around to here. And so now, if you like, it's been moved pi on 2 minus theta, because this is pi on 2 up here. So we now have a new triangle up here. And what's actually happened here is that our A, which was the horizontal, is now our vertical. And our B, which was the vertical, is now the horizontal. So if we draw a line down there, that's the same triangle obviously, but this angle here is pi on 2 minus theta. This value here is A, this value here is B. And so what we can say from that is that sine of pi on 2 minus theta, remember sine is opposite over hypotenuse, our opposite there would be A, and our hypotenuse is still 1 because it is a unit circle, so it's A over 1. Now we know from our original circle that sine pi on 2 minus theta, that A was equal to cos theta, so therefore cos theta. So that's where we're getting these new relationships from. And so the others also follow the same way. So cos of pi on 2 minus theta is equal to sine theta. Have a look at your diagram there, because cos of pi on 2 minus theta would be adjacent over the hypotenuse, so it would be B over 1, and B was sine theta. And here is another 2 from this diagram over here, where we bring the actual triangle pi on 2 plus theta. So sine of pi on 2 plus theta is equal to A, cos theta, which is cos theta. Cos on pi on 2 plus theta is equal to minus B, which is equal to minus sine theta. It might be a good idea just to memorise those rather than having to work them out all the time. So let's have a look at this example. We know that sine of theta is 0.3, cos of alpha is 0.8. The question says find the values of sine of pi on 2 minus alpha. So we know from our complementary relationships that sine of pi on 2 minus alpha is equal to cos of alpha, and of course cos of alpha is equal to 0.8. The next one, cos of pi on 2 plus theta. Cos of pi on 2 plus theta, that's where we move the triangle right around into the second quadrant, and so that gives you minus sine theta, and we know that sine of theta is 0.3, so that must be negative 0.3. And this last one is just a negative angle, sine of negative theta. We know that sine of negative theta is negative sine theta, and therefore negative sine theta is negative 0.3. So it would be well worth your while committing some of these to memory. It makes perfect sense that if we said that this distance here is equal to cos theta and the y distance is sine theta, then cos squared theta plus sine squared theta is equal to the hypotenuse squared, because that's Pythagoras' theorem, and that's what we call the Pythagoras identity. Now you could use that in the next example, but I like to do it this way. So have a look at the way I've chosen to do it. We know that we are working between pi on 2 and pi. So where am I working in my quadrants? That is in the second quadrant, and I know that sine is positive there. And I'm told that sine of x is equal to 3/5. I want to find cos of x and tan of x. So what I might do is just start off by drawing a triangle. And because sine of x is opposite over hypotenuse. And remember, we're told that sine of x is equal to 3/5, which would mean that the opposite, if I put my theta down here, my opposite is 3 and my hypotenuse is 5. Now, using Pythagoras' theorem, to find the third side, it would be the hypotenuse squared minus the opposite squared. 5 squared minus 20 minus 3 squared, 25 minus 9 is 16. So the square root of 16 is 4. So it's a 3, 4, 5 Pythagorean triple. Some of you might have noticed that before. Well, we're nearly there. So we're asked to find cos of x. And we know that cos is equal to adjacent over hypotenuse. In this case, it would be the adjacent, which is 4, over the hypotenuse, which is 5. So you could tell me, therefore, that cos of x is equal to 4/5, but not quite, because you've got to consider the domain here. And we are working in the second quadrant. Is cos positive or negative in that quadrant? Well, we know that sine is the only one that's positive. So therefore, my answer here must be cos x equal to negative 4/5. So you do need to consider the domain that you are in. If my domain was pi to 3 pi on 2, then it would have been a positive 4/5. And the other one here, I need to find tan x. And we know tan is opposite over adjacent. My opposite is 3, my adjacent is 4. And again, I'm in the second quadrant and tan is negative there. So tan x is equal to negative 3/4.